Now we are going to see how to simplify a Boolean expression. As I discussed several Boolean laws, I actually got several laws here to just to get an idea. Now we have around 12 or 15 laws, but most of the laws are not used for simplification. I have taken several laws. So A and 1 equal A. One law here on useful law. AO1 equal 1. AOA equal A. I have reduced number of laws because the difficult thing is actually selecting those laws for a Boolean expression. So that's why I have taken a few of them here. And I think you may have remembered important laws called distributive law. Here we have two forms of distributive law. Distributive law is the most wanted, actually, useful law for a Boolean expression. So I have taken it A and B O C equal A and B O A and C. Another law AO B and C equal AO B and AO C. These two laws are useful. Then after that, De Morgan law can be seen in some cases. De Morgan law. Later on, actually, redundancy law. Redundancy law, there are two forms of redundancy law. AO A and B equal A, and AO A bar and B equal AOB. I suppose if you try to remember those particular laws, you will be able to simplify the given Boolean expression. Right. In the teacher's guide, they have given 4 examples. So I actually select more than 4. I have several examples here to discuss with you. First of all, we see the examples given in the teacher's guide. The first example, it would be like this. It says A and B and C O. A and B and C O. A bar and B and C O. A and B and C bar. This is the given Boolean expression for simplifying. One point you have to remember, if you have a Boolean expression, first see there are some terms. There are some terms which can multiply. Which can multiply using the given terms. If there are no such things, here we need to Actually, O. We need to add them. O and O are the main operators. Then what you can do, you need to try to find out the common terms from the given expression. What we can do, we can take them out. We can take them out. That is now we can take the Boolean expression out of the statement fact. So let's see how to get something from the given statement. Here we have A and B and C. We are unable to find out A and B and C here, or A and B and C. But what about A and B? Here we cannot see A and B, but here we can see A and B. C and C bar. So what we can do, we can take A and B. A and B is common for both. A and B is common for both statements. So then what you can do, you can take A and B out. This is distributive law. Why? According to distributive law, you can see if there are common things, you can take them out from the expression. Right. We apply the distributive law. So we take A and B out, and then C bar remains here. O, the next term A and B and C. What is the law? What is the law you use to get this expression is redundancy law. So you, not the redundancy law, distributive law. So you have to write it. Distributive law. This is the first statement. We have taken the common things out. Then after that, you check the statement again. Check the statement again. What may happen? C or C bar can be seen. C or C bar. If you see C or C bar, it is something like this. You may have heard this type of statements here. C or C bar. If C is 1, C bar is 0. If C is 0, C bar is 1. So what may happen here? C or C bar should be 1. So we can simplify here. It should be 1. Then we have A and B, O, A bar and B and C. No need to mention the name of the rule here. Instead we say A, O, A bar equal 1. A, O, A bar equal 1. So that's why we get 1 here. That is the reason. That's why we get 1 here. So now we have the statement like this. This time we have something within brackets, so we can multiply it. A and B into 1. See, A and 1 into 1 means A. A and B into 1 means A and B. A and B, O, A bar and B and C here. Then I write the rule. It should be A and 1 equally. That is the rule we have used here. So we try to get such rules. Now what we have A and B, O, A bar and B and C. Now, what is the way? We need to understand whether there are, there are common terms. A is not common. B is common. A is not common, but B is common here. B and B can be seen here. B and B. C is not common. So what we do, we take B out. We take B. And then A, O, A bar and B remains. Again, what we did, we use distributive law. Distributive law. Right, now still we are in the expression. Now we cannot stop it. We will actually think about the laws here. And we now we have actually reduced something, so we do not go to multiply. The thing is, you have taken the common thing out, so again we cannot multiply here. So instead, what we do, we are going to see that A, O, A bar and B. Something called A, O, A bar and B. No, it should be not B. We have taken B out here. A, O, A bar and C. See? A, O, A bar and C. Now, from these two B, we have taken out B. So it remains C here. Now B and A, O, A bar and C. What about laws from here? We have redundancy law. It says A, O, A bar and B. See, A, O, A bar and C. A, O, A bar and B. Now it is similar to that A, O, A bar and C. So we can apply redundancy law here. If we apply redundancy law here, B is out of the term. A, O, A bar and B means A, O, B. So it will change as A, O, C because of redundancy law. So we say redundancy law. Redundancy law. Now we cannot apply any law here. A, O, C, different terms. We don't apply here. We cannot multiply it again, because if you do it, the same distributive law, it will expand the term. It says B and A, O, B and C. So we need the smaller one. But we take the smaller one. So this is the final situation. So we have reduced it up to B and A, O, C. The statement, the given Boolean expression with the support of distributive law and some basic rules such as A, O, A bar, A and 1, and again distributive law and redundancy law. Now this is the first example they have given in the teacher's guide. I think they may have used different rules here. It can be because sometimes they think about different rules and get the same output. The output should be same. If you use any different law, it is not a big problem, but if you can reach into the outputs, it's okay. That is the way. Right. Now you need to, now, I uh, explain this simplification part with the support of these laws. So you are going to, this is not the end anyhow, this is the beginning. So after practicing these things and after getting the idea properly, it takes times. Some of you may have understood this properly, but others need more time to be familiar with Boolean expressions here. So then they can do, right. So I train all of you in order to simplify the Boolean expressions in the exam, right? Okay, let's see the next example. What is the next one they have given? Um, for practicing, I have written those theories like this, but in the exam, no need of writing them. Now, you should practice this and then remember the rules. The second, this is the second one, it should be something like this: A or B, in bracket, A or B, and AOC. AOC, AOB, and AOC. Now, once we see, yes, AOB and AOC. Now, when you think about form of distributive law, AOB and AOC can be seen here, but you cannot say directly this is the distributive law, so you can take the smaller form, but you should try to show something here, right? Otherwise you see the answer A, O, B and C, because this is the distributive law. They have given the opposite form here, but we don't mention it as distributive law. Instead, we are trying to do something. Both and, this is and. Both terms. So if there is a and situation and the brackets have used here, you need to multiply them. So take the first Boolean variable A, and we are going to multiply from A here, A and A. So we say A and A, A and A, O, O, A and C, A and C. Then after that we have O operator here, because we moved the second part, O, because O operator here. But this expression should be multiplied by B, B and A. You can say it is a B and A, BA, otherwise AB. And B and C, it is B and C. So after multiplying, what is the reason for multiplying them? Multiplication is here, so it should be and actually. Then we see brackets, so then we expanded the statement. But aim is to make it more smaller. Aim is to make it more smaller. What are the rules? Now, in such terms, there are 4 terms here. The thing is trying to get common terms. But before trying to get common terms, see A and A. A and A. You may have remembered some rules like this. A and A. A and A is A. So directly you get it. A and A means A here. And with A and C, O, A and B, C. What is the rule? This is B and C. We applied A and A equal A. It's a common term. So then what we are going to do, right? Okay, then after getting this statement, the thing is try to get in common terms out, as well as try to find out some theories like redundancy, De Morgan. Actually, there is no specific rule what to do now. Taking the common terms out is one method, but before taking them out, see if you can recognize some situation like A, O, A and B in a given a statement. Here we see A, O, A and C, A, O, A and B. Now A, O, A and C means a different idea here. But directly you can get it, but family one A, O, A and B is here. Even you can take A, O, A and C, but A, O, A and B here. A, O, B and C here. But we can take. I would like to take A, O, A and B. A, O, A and C here, A, O, A and B here. Both are acceptable, both statements can be taken to reduce something. So I take A, O, A and C. A, O, A and C become A. Now I say A, O, A and B, O, B and C. Rule was redundancy law. I saw redundancy law here. So I directly applied A, O, A and C is A. A, O, A and C is A. That is a redundancy law. Now what has happened here? Here even we can see A, O, A and B. Now the same law is here. So A, O, A and B means A. Again we reduce it. A. Then A, O, B and C. We have applied redundancy law again. Redundancy law. We applied redundancy law again. Now A, O, B and C. A, O, B and C. It means B and C means two different variables. That is not the redundancy law. We are unable to reduce it more. So answer A, O, B and C is the simplified answer. That is the simplified answer. We cannot apply. If you can see some rules here, there's the most important rules. De Morgan. Here, see A, O, B and C. A, O, B and C. What is this? This is distributive law. A, O, B and C. But here we don't mention distributive law. What we did here with the redundancy law, we removed it. We removed. So after applying the law here, we can mention here. I forgot to mention as distributive law here. It should be distributive law. Multiplication in the sense distributive law. Why? This is distributive law. The reason is distributive law says if something like this, see, A and B or C. We say A and B. Again A and C. It is very similar. We have something here and something here. So we multiply A and B. This is distributive law. So all the laws we have written here and come up to a certain solution, that is A or B and C. This is the second one they have given. Right, with the laws, we have tried to take or get the redundancy law. Most of the time we have taken redundancy law and with one abbreviation here. Right, now see the next example. Now the next example is CO B and C bar. CO B and C bar. Right. Now we are going to reduce it. We want to simplify. What is the idea? You see B and C bar, the long bar is here. If you see long bar against the statement, long bar, De Morgan theory can be applied. We have C, CO, B and C bar. So we write C here. O. The rule is very clear. Break in the bar and change in the operator. Now you have to change the operator from the B and is the operator. So we break the bar, B bar and C bar. So B and C bar, sorry, it should be O. We have changed the operator and here we change it as O. So then B bar O C bar. B and C bar equal. See. Now here we have use the second law, not the first one. The second law. So it says B bar O C bar. Now what we can do, write the law here as De Morgan. Say De Morgan's law. Now what we can do? Here we have C, B against C bar. We can apply CO C bar. CO C bar means 1. We say here 1 O B bar. What is the rule we have applied? A bar equal 1. A bar equal 1. So we take C bar. If C is 1, C bar is 0. So it should be 1. If C is 0 and C bar is 1, it should be 1. So then 1 no B bar. 1 no B bar. 1 no B bar means we can again apply the same one. Now, same rule. 1 O, we have 1 here and the B bar. So 1 O B bar means if B is 0, it should be 1. So 1 no 1 means 1. If B is 1, it should be 0. So 0 or 1 means 0. So it will reduce up to 1 again. 1 no B bar. Now we say A bar O 1 equal 1. If A bar 0, then it should be 1. If A bar is 1, then the result should be 1. So it is same. So we can abbreviate it as up as 1. So by using De Morgan's law, we can reduce the statement like this. Not only De Morgan, first time we use De Morgan, then after that A bar equal 1. So same thing. We then we have A bar O1 equal 1. So finally we have get the simplified answer as 1. What is the last example they have given? The last example is x. Teacher's guide says x and XOY. X and XOY. It is something like this. Situation to multiply something. So second part is within bracket. Here we have x. So again, before getting common terms, we cannot get common terms from here. We need to multiply. Right. Later on, we will do some examples here, but up to now, we say x into x, x and x here, or x into y, take x and y here. Now, after getting this one, after getting x and x, rule is what we did, we multiplied, this is distributive law, we say distributive law, and then x and x, this very common term, x and x means x. So we reduce it, x, O, x and y comes here. So we say the rule is A and A equal A. This is the rule. Now x, O, x and y. Can you see the redundancy law again? A, O, A and B. X, O, X and Y. The same rule can be seen with different term names. So we directly apply the redundancy law. It should be X. Answer should be X because of redundancy law. Right. Now, these 4 examples have given by them. Right. I would like to discuss few examples again with the next session. Right.